Welcome back to INST 314, Statistics for Information Science. We're wrapping up the module on statistical foundations with the last video on study designs. This is going to help us talk about the different ways that how we collect data in these different environments are going to speak to the different ways that we can try to generalize back to our populations of interest and the strength of our inferences that we can make. Let's get going. As I mentioned during the introduction, the lecture goal for this particular video is going to be looking at study designs. And let's go ahead and get started with it. There are three main study designs that we're going to be looking at. It's not the complete universe, but it's most of them that you're going to come across. There's observational, experimental, and quasi-experimental. The key differences between them are that observational relies on some sort of natural occurrences, natural phenomena, of which the researchers or data collectors and whoever's involved with the process, they don't have control over what's affecting those involved, what's going to happen with the outcome. Contrast that with experimental. Experimental is under complete, well, not complete, but highly controlled situations where the researchers and data processors will do their best to control every aspect of what happens between those involved and what's going to happen to them. That way they can identify anything that happens as being a result of the experiment instead of some external variation, things that they didn't control for. Quasi-experimental is that middle ground in between the observational and the experimental. It leans towards experimental, but there are, for various reasons and effects, things that make it difficult so they can't quite be experimental. Let's look at a little bit more and talk about treatments and controls. Now, these are predominantly found in experiments, but we can talk about them in any sort of context with study designs. So treatments are the forces and actions and other differences that we can create inside the predictor variable. We are inserting variation, or we are observing a variation that has been put upon others. And so those that receive this treatment are in a treatment group, and those that do not receive a treatment are in a control group. It is possible to have multiple treatment groups if there are different things that are going on with each individual group. But the differences between what happens in the treatment group and the control group is what we rely upon to the treatment effect. So with these observational designs, as I was saying before, they do not have control over how the treatment is applied. There can still be a treatment, but they just have to observe it passively, if you will, rather than being the ones that do it by intention. Taking this back to the experimental, this is the gold star method for our study designs as well, because it allows us to isolate out these treatment effects. We can use things like randomization to assign people to their different groups. And with that, we can really provide this baseline and understanding for the comparison. And that leaves us with quasi-experimental designs. I said before that they're similar to experimental, but there's going to be some sort of characteristics that really make it so that they are not experiments. And so the three predominant reasons is that they might not use random assignment. So the participants may not be assigned randomly to a treatment and a control group. They may be voluntary, self-selecting. They may be put into them by some other measure of a characteristic, such as a performance score, but it is not randomly done. It lacks a control group, could be another reason. If all you have are different groups that have treatments and none of them that have a control, there's no way to identify that initial baseline. And so it becomes a quasi-experiment in that regard. Or the treatments might not be explicit. The treatments might be part of some other greater forces that are enacting. There could be natural variation mixed in with the testable treatments. And so there's different things that are going on that makes it harder to identify what is the exact treatment going on. Now, if you can go ahead and get rid of these problems, like you could do random assignment, you can have a control group, you can have explicit treatment, then why not just have an experiment? Because it's not always ethical. Sometimes, if you are going to do certain things, especially when it involves people and often animals and things of this regard, when it comes to laboratory experiments for sure, we run into the challenges of ethics. And there are sometimes certain things that we're just not supposed to cross those lines. So sometimes it's not ethical to randomly put people into different groups if having some sort of treatment might be life-saving, for example. Other times it could be logistical. Resource constraints, monetary issues, maybe it's too much of an administrative challenge, but there's real world reasons why it's difficult to do that. And also there could be pre-existing groups, or it could be otherwise difficult to assign them and say, all right, you're going to be a treatment and you're going to be a control when they're already identified naturally. So I was mentioning before that why do we randomize? And this is something that just comes up again and again. So let's take a look at this as an example. Consider a study about exercise and test scores. Participants take an exam and then are given a choice of two groups, exercise or no exercise. The exercise group does 30 minutes of cardio at least 3 times a week, while the no exercise group has no requirements. After a month, the participants take a similar exam, and the researchers look to see if there's an improvement in scores. What might go wrong with this type of design? Go ahead and pause the video for a moment and think about it. Don't worry, I'll wait. Okay, so let's break this down a little bit. By allowing people to self-select into their groups instead of doing it randomly means that these people might select a group that meets their personal interests. So those that enjoy exercise may join the exercise group, and those that don't may opt not to join the exercise group. They will join the no exercise group. So in that case, we mentioned before in a previous video methods of selection bias. And so in this case, we have a selection bias here where people's self-selection could introduce problems with the sampling and the groups that we have. So by randomizing, we're taking away the self-selection potential. This brings us to control groups. Control groups, like I was saying before, if the common drug test is where one is a control and one is a treatment. And the difference between these is if you're doing the drug test and someone's taking a pill, then the treatment might be the actual drug, and the control group will take a pill, but it might be a sugar pill or something else that's non-harmful to the control group, but that's not also going to affect their treatment in any way. In that case, the control group is taking what we call a placebo. So I asked the question, what might you conclude if you found out that a drug reduced a heart attack by 10%? Well, if we did not have a treatment group and a control group, we wouldn't be able to determine if that 10% was coming from which group or both groups or where it's at. So then what if I said that you learned that the control group with the placebo had their heart attack reduced by 13%? Okay, well, now we have differences. We can say how much the control group or the treatment group went up or down, but now we're able to draw these distinctions with the treatment group. So what we're really getting at with these is to say if there's been a real improvement and if that improvement is due to a placebo effect. A placebo effect, coming from the question I posed above, was where the placebo had a change when there shouldn't have been a change. All they were taking in this case was a sugar pill. So that their risk of heart attack had been reduced by 13% for taking a sugar pill shows that either there's some other forces and factors and confounding variables, to throw in some jargon for you, that we hadn't considered that it could be affecting our experiment, or there is a placebo effect where, who knows, the power of mental thought or some other reason that they actually were doing better. So when we're talking about control groups and these sorts of things, there's something we can introduce called blinding. Knowing that you took the sugar pill may cause you to have other feelings, and we're really working on the neuroscience to see how much there's a connection between mind and matter, body and spirit, and things of this nature. And so the placebo effect is a real thing. You can go ahead and look it up. So we do something called blinding to help mask some of this up. We don't tell you if you're taking the sugar pill or not. So a single blind is when the participants don't know which group that they're in, treatment or control. A double blind is if the researchers also don't know which groups the participants are in, which keeps the researchers from having their own biases interjected as well. Remember I was saying before that there are many different types of bias in research in general, and so I strongly encourage you to go explore some of those that are outside of the selection biases we're covering in class. Just to kind of revisit this idea of causation, that the more rigorous you have your study design, essentially the stronger we can go towards experimental, and the sampling methods we use favoring things like randomization, simple randomization specifically, the stronger our potential to find the inferences that we're going to have. And if you want to make a statement about causation, you really need to have a randomized control study. The farther you get away from randomized control studies, the weaker your inference ability to make a statement about causation is going to be. And with that, thank you for staying with us to finish up the statistical foundations. I'll see you guys in the next module. Moving on.